Go ahead and get your mask on there, Francis.
Mask on.
We have, this was what you did for homework last time? All right. And we were looking at the different atoms, right? So, for instance, for beryllium, and just kind of going forward, I would strongly suggest to everyone, every time we do an assignment like this, is just to kind of copy over a periodic table because you're going to be using it all the time. And it's a lot easier to do it this way than keep going back and forth. So, and whenever you use a periodic table, I also strongly suggest to you that you just go ahead and kind of highlight this group right here, because this is going to be our standard group that we look for. Everything is going to be based off of that group of atoms. Remember what that group's called? What do we call that group? The something gases?
Noble gases.
The noble gases, okay? We call them noble because they're the kind of the snobby ones, the ones that don't interact with the other elements. So there are, and what we're going to talk about later is that these guys are stable. That's why everybody likes them. They're that good, consistent, stable friend that everyone depends upon. What? Yep, right now. You know me. I have to do all my digressions. Hold on. So we talked about this, and really for this assignment, the mass number is not that big of a deal. Let's just ignore it because it's annoying. But when we did this, we said that, for instance, lithium has an atomic number of 3. That means it has how many protons? 3, right? And if it's, we can have 3 here. For electrons, it'll be.
But you mean electrons 3.
Yeah, I mean, this can be 4 or 3. We can go 4. It doesn't really matter too much. But for what we're doing, it doesn't matter too much, right? So what about electrons? 3. Thanks. Perfect. Okay, so then when you do this, right, remember the levels go 2 electrons and then 8 electrons. So if we have 3, we're going to go 2 electrons here on the first level, and then what?
Make sure you check out the homework.
Okay, I will. And then 1 out there on the third level, right? So it starts filling at that first energy level first. So if there's more than 2, then it's definitely going to go to the second energy level. If there's more than 10, it'll go to the third and so forth.
Next.
Okay, so no big deal, right? Now, here's where we're going to do I told you all to wait on the second column. We're going to do that second column right now together.
Go.
Okay, the lithium ion. Now, what is an ion? An ion is a charged atom, and it's charged because the protons do not equal the electrons. Okay? Fix that. Now, and the reason why is because electrons are gained or lost. We just talked about on the test how the neutral atom, the protons and the electrons are the same. So if there's a difference and we don't change protons, right? Right? Everybody get that in your head. You do not change protons. If the electrons are changed, if they're gained or lost, then you're going to have a charged ion or a charged atom, which we call an ion, right? Now, there's two different types of charged ions. There's cations and there are anions.
So sorry.
Okay? There's cations and anions. Okay, the cations have a positive charge. How do we remember this? Well, remember that cat has a little plus sign in the middle of it, so it's positive. That's how you remember and tell them apart. Right? See the little plus sign, Caitlin? Little plus sign in cation. So when you see cation, it's a plus. See? Okay. Just a little memory device there. Now, this is the one thing that students oftentimes forget because they think if something is lost, then it's a negative thing. But remember, electrons are negative. So really what happens is they're losing negativity. Okay? So if you lose negativity, you become a more positive person, right? The atoms lose negativity, they become more positive. So positive things have lost electrons, right? And thus also if you gain negativity, then you become negative, right? So anions gain electrons, become more negative. Cations lose electrons, become more positive. And we'll say that over and over again. You'll get used to it. You'll hear cation and anion all the time. All right? Questions? Everybody got that? Okay. Now, here's where we need the periodic table. If you talk about the lithium ion, these are the same every single time. Atomic number is 3, protons is 3, right? Neutrons, we're not going to change, it's still 4. Now, the electrons are going to change. Now, how do we know that they change? Well, or how do they change? Here is the big reminder, the big thing to keep in mind is this right here. Oh, no, that's not good.
Yeah, I know.
Well, why do you think that is?
I'm not sure.
Oh,
Mr. Chairman, can you just go over the bottom part?
we're going
Can
to.
we just go through it like rapid fire?
Well, we would, except for you have to understand this. You have to understand how to do this.
No, I think I understand.
All right? The point is that when atoms gain and lose electrons, they are doing so to become stable. Now, which group do we know is stable?
Got one.
That group. Okay? So, I will say this 100 times in the next 2 weeks, I guarantee you. Atoms gain or lose electrons to become like the nearest noble gas. Okay? So, the arrangement of electrons that you see here, 2, 10, 18, 36, 54, 86, 118, that's stable. So all atoms are trying to be like that because they want to be stable. That's the goal. All right, nature likes things stable. So when lithium becomes an ion, it wants to become like its nearest noble gas. If it has 3 electrons, what's the closest noble gas to 3? Is 3 closer to 2 or 10? 2, right? It's not a trick question. 3 is closer to 2 than 10, right? So what does 3 have to do to become like 2? Reduce 1, right? Lose 1. So it loses 1 electron. All right. So instead of 3, it's going to have 2. All right. And its setup will be like this right here. Now, if you lose negativity, what happens to your charge?
No.
Shh. Wait a minute. Listen. Shh. If you lose negativity, shh, Maddie. If you lose negativity, do you become more positive or negative? Losing negativity makes you more positive, right? Okay. Shh. So it loses 1. Loses one electron, so the charge becomes +1. For lithium. Now, why is that? Well, lithium has 3 electrons. Well, I'm going to show you in a minute. It has 3 protons. Right? So if we get rid of one of those electrons, now we have an overall +1, which means that the charge on lithium is +1. And it's a cation because it's positive. And now here is the symbol. Li +1. Yes.
Did we get out early tomorrow?
Yes.
At what time?
Noonish.
Maybe.
Okay. So lithium +1. That's the That's the symbol. Okay. No big deal. All right. Let's look at beryllium. Okay. What's beryllium's atomic number? Shh. Look at our periodic table. Again, I told you we're going to be doing lots of periodic table stuff. What's beryllium's atomic number?
I'm looking for my stapler, but here
Oh.
be gone.
Okay. Shh. I don't think anybody used a stapler, did they? Anybody use a stapler?
No.
See the stapler? Oh, I don't think I've seen it. Okay. Yeah, I haven't seen it.
No, all right.
All right. So, beryllium has how many electrons? Shh. Huh? I'm sorry. How many protons? Oh, come on. It's right there in the periodic table.
Wait, go back.
4. Beryllium.
4.
Oh, 4.
Okay. So we have an atomic number of 4.
Oh, so we don't have to do the caution in whatever.
Do the what?
C/A thing.
No, we did for the first one.
Oh, you just
If it's positive, it's a cation. If it's negative, it's an anion. That's it. Nope, that's it.
Wait, can you scroll up a bit?
Okay.
Oh.
Oh.
All right, so that means that it has 4 electrons. Here we go. 1, 2. First energy level is filled. And we can put 2 more here. Doesn't really matter where they go.
I swear.
Okay. So there's 2 in the first and 2 in the second level. Now, if we talk the ion, the atomic number is going to be 4 still. All right, that doesn't change. Protons don't change.
Not all.
Hey.
That was giving you purple lips.
Okay. Now, which noble gas number is beryllium closest to? Beryllium's 4. Remember, it can be either like 10 or 2. Is 4 closer to 10 or 2? 2. So, what does 4 have to do to be like 2? Lose 2, right? So, it loses 2 electrons. So that means it's what charge?
No.
Listen, please. We're losing negativity, so we become
Oh, positive.
positive. We lose 2 negativities.
Negative.
We lose 2 negative ones, so we become plus 2.
Next.
Okay? Everybody see why that is? There's 4 protons for beryllium.
I don't have any. No, then how are we going to do it?
If you only have 2 electrons, and you do because you lost 2, there's going to be 2 positives left over. That means plus 2. Okay?
So it'd be D equal what?
Now, notice that beryllium and lithium have the same ion model because they are going to the same noble gas, helium. That means that we have 2 electrons. Is it a cation or an anion? Cation because it's positive. The ionic symbol is Be plus 2. Okay?
Wait, what's the ion symbol for the lithium?
Li plus 1.
Oh, man.
Okay?
We have a lot to go through, so I think we need to get the gas.
Oh, no, we don't necessarily have to go through all of them. I want you to make sure that you all know how to do these. That's my goal.
I know how to do them. Wait,
No,
you said that we only
I don't understand yet.
lithium, like the autumn column.
Right. So you guys have done the atom one already. We're doing the ion one today.
Oh, we didn't have to do the ion column?
Yeah,
No.
that's what we've done.
Oh.
Okay? Let's go on.
Oh, I wasn't done already.
Pissing me off. What is trying to
Shh.
go back up a little more.
No, I'll just take a picture for you.
Okay? So, think ahead to boron. Shh. Boron's the next one.
11, 5, 6, 5.
Okay? Sorry. You have 5. Again, it doesn't matter on the thing, on the mass number, but we'll do that for fun. Okay? 5. And thus boron should look like this in the model form with 2 at the first level, 3 in the second. Now, it should be on all of them that these first 4 columns or first 4 rows are the same for both atom and ion. It doesn't change. Okay, the only thing that's going to change is the electrons. Now, boron is 5. Is 5 closer to 2 or 10? 2, right? What does 5 have to do to be like 2?
3.
Lose 3, right? That makes it what charge?
Positive.
Plus what? 3. Okay? So that means you're going to have 2 electrons. Notice it's just like the helium before. The ion symbol will be B plus 3, and it is a cation.
What's this? B plus 3.
B plus 3, yep. It's just the element symbol
Can you go over?
with the charge. Like this. Okay? Now, notice that on this that we skipped an element, didn't we? If you look up there, this is nitrogen now. I'll just put this on here. I'll put this on here for Elena because she's watching from home. Sorry, I'll be right back. We went from boron to nitrogen. What? Well, she's not on, but I'm videoing it for her. You can say hi to Elena. Say hi, Elena. Hi.
Hello, Elena.
Hi.
Congrats on getting 100. So proud of you.
Yay, good job, Elena.
Wow.
Now, okay, so we have boron and nitrogen is next, right? It skips carbon. Why is that? Well, because which is carbon close? Which is 6 closer to 10 or 2?
10.
It's the same, right? the same distance. So carbon is actually this column right here. These ones can be either plus or minus, and it's hard to predict. It's based upon what they're with. So we can't really predict those. That's why we skipped them there. And we'll find out that carbon and silicon are very kind of interesting elements. They do lots of really, really cool things, right? What does carbon do that's really cool? It's really good. And we're really happy that it does it.
Oxygen.
It's the basis of what?
Life.
Of us.
I
Of
just
life.
said that.
Yeah, of life. Carbon is the basis of life, right? And that's because carbon is a super, super flexible little atom. And it can do lots of different things. So what is silicon the basis of? And don't say implants. It is, but that's beside the point. What is silicon the basis of?
Rubber.
Technology.
Yeah. All of these chips and stuff we do are silicon based because it also is a super flexible little atom. That can do lots of different things and flow with electrons at lots of different rates. So, okay, my digression is over. I'll go back. Hold on.
Thank you, Mr. Sheldon.
Now, there you go. Is that what you need?
Yeah.
All right. So, going on to nitrogen. Nitrogen is what atomic number?
7.
7. Means it has, and we can do 14, whatever. That's fine. 7 protons, 7 neutrons, and 7 electrons. Same number over here. Oh, no, don't do 7.
Use the middle. Thanks.
Okay. 1, 2, 3, 4, 5, 6, and 7.
How many are on the second?
So then there's 2 on the first and 5 on the second.
Oh, Steely. Hang on.
I don't think you're gonna like it.
Whoa.
All right. Now,
Dang it!
Well, that's okay now.
are you okay now?
Oh.
All right. Well, let's take a look then. 7. Is 7 closer to 10 or to 2? 10. So what does 7 have to do to be like 10? Gain 3. So it's going to pick up 3 electrons instead of lose them. Now, so this is going to be different. So this is going to be a -3 instead because it's gaining negativity. Electrons are negative, right? So, Maddie,
Yes.
put it down. Now, so if we add 3 to 7, we get 10. All right. Element symbol N minus 3. Okay. So, is that a cation or an anion? An anion. It's negative. Got it? And then, do you like dots or X's better? I can't decide. We'll try this one with dots. 2, 3, 4, 5, 6, 7, 8, 9, 10.
Why are they dots now?
I don't know. I just you like the dots or the X's better? I can't decide. You like the X's better? Okay, I'll do the X's then.
Oh.
I didn't mean to erase it.
Well, I want it to be nice and perfect. Oh, well, it's perfect.
Is that 5 or 7?
Hold on. This is a 7.
So there's 2 on the inside and 8 on the outside.
Yep. Okay.
Oh, that's not bad. I got it. Here.
All right.
It's literally what's better than I think this house.
No big deal, right?
Wait.
Sorry.
We have to take a-
All right. So Look ahead while they're writing it down. Look ahead to oxygen and see if you can predict what's going to happen.
What's wrong with it?
Oh, it's great.
I think it's beautiful, Maddie.
Thanks, Mrs. Tom.
Wait, yeah, for
What do you complain about now?
everything.
Everything.
Mm. So it's another day that ends in Y, huh? All right. Okay, so now we're to the change. What's going to happen?
Where's the medicine?
We, Sam.
Are you gonna fix my grade like before class is over?
Me too,
Yeah.
Mr.
Me
Truman.
too, Mr. Truman. Can you go over a little?
Would it be two?
Hey, would it be two?
It's going to gain 2, right? So it should be yes, minus 2, 10 electrons, O minus 2, and that is an anion.
Whoa.
All right?
Okay, go to the circles now.
Okay,
Balls.
so this is
More over. No, yeah, that way. There you go.
this is going to be exactly the same as the nitrogen one we just did, because it has 10 electrons, so it has the same setup as 10 electrons.
How many's on the other one?
Oh, this is so beautiful.
Okay, yeah, there's 2 in the first circle, 8 in the second.
Oh my goodness.
I need that spare one.
All right,
Well, just let me finish.
I'm not doing anything now. Does everybody? Everybody's starting to get how to do these.
Yeah, but no, actually, keep
Okay,
going.
All right.
I think I need like the alternate.
Yeah.
When did juniors get out today?
All right, let's do this. Now,
Wait, did we actually get out last?
I have no idea.
You myself. I mean,
I'll wait my
today.
All right, moving down. Shh. Leah. Okay, so shh. Our atomic number then for fluorine is 9. Go 18.
No.
Maybe Suresh.
2. Do a pass.
Okay.
Did you know?
Mulligan, the band teacher, he gave me 2 demerits for eating in class. I hate him.
I'm sorry.
Oh,
Hate's a strong word.
no, I don't care. I hate that man.
Okay. So that's going to be the model. We have the same numbers over here. All right. Is 9 closer to 10 or 2? 10. And what does it have to do? Gain 1, right? 9 gains 1 to be like 10. That's a negative 1 charge.
So,
F minus 1.
Is the electrons always been?
They're going to be either 2, 10, or 18.
is it the cation or anion?
Anion.
It's an anion because it's negative. And same game on the ion. It's going to look just like the last 2. Okay? And that's it. Again, these atoms are going to stability. 2, 10, and 18 are stable.
Can you go over the other one?
Okay? Which one?
The other X's.
Oh,
After lunch in the car?
Yeah.
okay.
What are you gonna eat?
Any questions on that? Everybody get that?
Go during art.
Now,
It's office lets you.
so then the next row, which I think is what you need to do. Did you get all that, Natalie?
Yeah.
I'm gonna ask
All right. Down through the next row. Shh. You are going to do the same exact thing, only you're going to go to between 10 and 18. Is it going to be closer to 10 or closer to 18? Because as you see, the next atoms are in between from here and here. So they're between this 10 and this 18.
Oh, we're not gonna like finish it?
I mean, we can. We're just running out of time. I don't
No,
want
I'd
to.
rather you put my grades in.
Okay.
How do I
Can
look
you
at
just-
Wait, don't put in my grades. I'm missing one
Can you just like write down the answers and then we can look check our answers?
Yeah, do that.
Okay, well, why don't I do this? I'll start to do everyone's grades, and then somebody remind me at 11:05, and I'll write down the answers. But start working on them. Okay? All right, everybody tell Elena bye. Bye, Elena. See ya. Hope you come back soon.